Hi everyone, this is Kiranmay from H&S department. Today in this session, we are going to discuss about semiconductor laser diode, which is an optoelectronic device which is made up of semiconductor materials only. Coming to this session, we are going to discuss about the key points of a semiconductor laser, construction of two different semiconductor lasers like homojunction and heterojunction, and how a semiconductor laser will work, what are the characteristics of it, merits and demerits, and their applications also. First of all, what is a semiconductor laser? Semiconductor laser is otherwise called as diode laser. It has a very important application in fiber optic communication, as optical fibers works on only light energy because they carries only light energy, light radiations through them. Those light radiation source will be a diode laser. So these diode lasers play a vital role in the applications of fiber optics in many fields. The wavelength of the emitted light depends upon the band gap of the material. As the material changes, the output also, wavelength of the output also changes. That is, lambda is equal to hc by eg, where h and c are the Planck's constant and velocity of light. By substituting those values, we can get the value like 1.24 by eg micrometers. So depending upon the energy gap, the output wavelength also changes. If the material is having more energy gap, then the output will have less wavelength. If the material is having less energy gap, then the output will have more wavelength. And by using the materials, preparing for the fabrication of semiconductor lasers, we can segregate these semiconductor lasers into two different types. One is homojunction semiconductor laser, another one is heterojunction semiconductor laser. If a PN junction is made of the materials which are belonging to the same element, that is both P and N type materials, same material is taken, and for the same material, if a trivalent and pentavalent elements are doped and P and N type materials are fabricated, then junction formed by those materials, we can call it as homojunction. If a laser diode is made of such a junction is called as homojunction semiconductor laser. For the fabrication of P and N type materials, if different basic semiconductor material is used, that is for the fabrication of P type material, one semiconductor material, and the fabrication of N type material, another semiconductor material is used, then then the junction formed by those P and N materials is called as heterojunction, and the laser diode fabricated out of that junction is called as heterojunction semiconductor laser diode. So coming to the principle of a semiconductor laser diode, here we are supposed to take a PN junction diode, either it may be a homojunction or heterojunction. Always the junction should be forward biased. That means the P-type material is always connected to the positive terminal of the battery, and N-type material is connected to the negative terminal of the battery. Then, when it is forward bias, due to the repulsion from the terminals of the battery, carriers will move from one side of the junction to another side of the junction, and at junction, holes and electrons recombine with each other. Holes will move from P side, electrons will move from N side, as they are the majority carriers in those materials, and at the junction, those two will recombine with each other. Due to recombination, energy will be released in the form of photons. These photons further stimulates the recombination rate, and hence a laser output is obtained. That means, due to recombination of electron hole pairs, photons will be released. These photons are stimulated. Stimulated means they get their number increased due to more and more recombinations. Again, these photons, stimulated photons, collides with more and more atoms and produces electron hole pairs. Hence, these pairs will move towards each other, and again recombination rate increases. If recombination rate increases, photon number also increases. Hence, we can get a laser output. Coming to the first type of semiconductor laser diode, that is homojunction semiconductor laser diode. In the name itself, it is mentioning that we are supposed to take same type of materials for the fabrication of P and N junction. Here, it will be gallium arsenide. We are supposed to take gallium arsenide crystal, which is doped with suitable ones, so that a p-type and n-type materials are formed, and they are joined together to form a p-n junction. But the dopants, whatever we are supposed to take, they are heavily doped to gallium arsenide, so that the carrier concentration will be high. As the junction, at the junction, the sides of the walls are sides are through which emitted light is coming out are well polished and parallel to each other, so that whatever the light which is coming out of the junction will be very intensified. Two metal contacts have been taken, one from the p-type material and from the n-type material, which acts like cathode and anode. Since p-type and n-type materials are made up of same material, then the p-n junction is called as homojunction semiconductor laser source. On the screen, you can view the constructional figure for a homojunction semiconductor laser, where you can observe that a p and n-type materials are joined together due to which an active region will be formed between them, and two contacts have been taken, one from the p-type material, another from the n-type material. So they will act like a cathode and anode, and these surfaces from where we are getting the laser output, they are like they were well polished and parallel to each other, this one and this one. One on the back surface will be a fully polished surface, whereas on the other side it will be partially polished surface. So this was the constructional structure for an homojunction semiconductor laser. So coming to the working of homojunction semiconductor laser, it is very similar to the heterojunction one also. When a current is passed through the p-n junction, what happens? Holes will be injected from p region to n region, because those are the majority carriers in p-type. Similarly, electrons are injected from n-type to p-type because they are the majority carriers on n-type. So when they are injecting from one region to another region, they will become minority carriers on the other region. For suppose electrons on n side, when they injected from n to p, in p region, these electrons are the minority carriers. Similarly, the holes which are getting injected from p-type material to n-type, they will get minority carriers on n side. So these electrons are minority charge carriers on p side, and holes are minority charge carriers on n side. The excess minority charge carriers recombine with majority carriers of the n and p materials, resulting in release of photons. See, further emitted photons increase the recombination rate, and thereby increasing the output. But the only disadvantage from the homojunction semiconductor laser diode is the output will be a pulsed output, discontinuous output, which can be overcome using an heterojunction laser. That can the best example for the material is gallium aluminum arsenide. So on the screen, you can observe the energy level diagram where when you give the electrical energy to the material, what happens? Electrons from n side recombines with a hole from the p side at the junction. Therefore, the energy will be released in the form of radiations. So this is the recombination of electrons from conduction band to valency band, where they will recombine with holes, and due to de-excitation of these electrons from higher to lower energy level, energy will be released in the form of radiations. So coming to the heterojunction semiconductor laser, the construction consists of a gallium arsenide, which is sandwiched between two different p and n materials, which are made up of gallium aluminum arsenide. So this layer gallium arsenide is in between two gallium aluminum arsenides, which is having wider energy gap and then lower refractive index. But the thickness of this gallium arsenide, which is sandwiched between gallium aluminum arsenide, should be very small and with of high refractive index. This gallium arsenide, which is in between gallium aluminum arsenide layers, it will work like an active region where laser action takes place. Again, the front and rear face is polished parallel to each other and will act like an optical resonator. So on the screen, you can observe that this middle layer which is blue in color, that is of active region, which is made up of gallium arsenide. On both sides of this active region, you will find green color, which one is like p-type substrate, another one is n-type substrate. They will work like p-type and n-type. This active region will be the junction between them, and from both sides of p-type and n-type materials, two contacts had been taken, which work like electrodes. Then coming to the characteristics of semiconductor laser diode, uh, here we can see the characteristics for the output current and output light intensity. So below the threshold current, the output is due to minority charge carriers. Hence, the value is very less when it is below the threshold current. Below the threshold current, the current value output is very less because of less current at the output. So uh, further emitted photons, if you increase the current, if you increase the input, what happens, more and more current will be produced, more and more recombination happens, hence light emitted also increases. So further emitted photons increase the recombination rate, current increases sharply after threshold current, hence the light output also. So beyond beyond beside sorry below threshold current, the recombination rate is very slow, hence there is no emission of more carriers inside the material, hence the light output is also very less. Whereas beyond threshold current, current increases sharply due to increase in recombination rate, hence output light is also high. Coming to the merits of semiconductor laser, these are cheapest, smallest lasers available, massively produced and easily fabricated. Laser output can easily be modulated and highly efficient. So we can fabricate them in large number, and they are cheapest and smallest materials what lasers can be fabricated, and the output is easily modulated. Coming to the disadvantage, it is very difficult to grow different layers of PN junction, and the cost of fabrication is very high for the heterojunction semiconductor lasers. Applications. The main application of laser diode is fiber optic communication, metal cutting, welding. Lasers are widely used in electronic industries for trimming and components. The lasers are used to destroy kidney stones and gallstones. Lasers breaks the stones into small pieces, and these are used in cancer diagnosis and therapy. Lasers are used in blood lossless surgeries also. These are the some of the applications what laser found in our day-to-day life. Thank you.